everyone. I think we're going to go ahead and get started with the next talk here. So this is, thank you very much for giving me the opportunity to come and speak with you about accelerated compute on Google Cloud Platform using NVIDIA GPUs. I'm Alexander Tsado. I'm one of the product marketing managers with the group at NVIDIA, selling our accelerated compute solutions on the cloud, working very closely with Google. So first of all, we're going to start by talking about science, since we're at a science conference. The charts I have over here, the first chart is showing you Moore's law. What is common knowledge is that for compute to keep up with science demand, it has to grow at 1.5x every year. And Moore's law has been fantastic at doing that since the 1990s. However, that started to slow down, as you can see over here, from 2010. And so it's required a new way to meet up with the demand. A little anecdote I'll tell is, say you're trying to buy a yacht and you go speak with your financial advisor, and one of the first questions they'll ask you is, what's your annual cash flow? Or how much do you save every year? Then, for instance, you tell them it's $50,000. I'm sure at that point they're going to tell you, okay, maybe forget about your dreams, or pretty much you have to make a drastic change to the way you're going about saving for this yacht. You can't just go from $50,000 to $55,000. You have to go to $500,000. That kind of transition is what we're talking about here with GPU accelerated compute, going from the blue line to the green line. And that is what's being applied across industries, consumer internet industries, industrial applications, and high-performance computing simulations, as we'll be talking about here today. At NVIDIA, we provide a complete stack from the hardware layer with the GPUs you're all very familiar with, to the software, several layers of the software, going from the SDKs and libraries in deep learning, HPC, and machine learning, which I'll talk about soon, and the applications, accelerating frameworks of deep learning, accelerating applications in HPC space, over 580 of them, across different use cases. At supercomputing, we're very excited to talk about the supercomputers that are using NVIDIA GPUs, and also excited to tell you about how you can leverage those same supercomputing power in Google Cloud, how you can run that to work on your life's work. We've announced several months ago Summit being the fastest supercomputer in the world, but beyond Summit, NVIDIA GPUs power the second fastest in the world, Europe's fastest, Japan's fastest, and the fastest industrial computer in the world. And for the price of lunch, you can rent GPUs with similar power on GCP and scale it up with Kubernetes to work on some of your life's work and innovate. That's actually what we're most excited about at NVIDIA, is what people are using the solutions to do. This slide is talking about the Golden Bell Awards. I don't know, I think a couple of folks here should be familiar with the Golden Bells. It's sort of like the Oscars or the Grammys for music. There are 6 nominees, and 5 of them this year are using NVIDIA solutions for their work, and it's really phenomenal. 4 of which are actually combining HPC and AI to accelerate their workloads hundreds of thousands of times. Not 10x, hundreds of thousands of times. It's incredible. I'll just touch on maybe 1 or 2 of them. On the far left is genomics. It's a genomics example where they've seen that 10% of people who use opioids are actually susceptible to getting addicted. And so what they're doing now is running simulations accelerated with AI to understand and see the correlations between our genetic makeup and being susceptible to getting addicted to an opioid. And the second example is about weather simulation. There's a lot of talk about climate change. Is the weather going to increase by 1 degree or 2 degrees on average? Is the sea level going to rise 1 feet? It's very, very important for us to know these answers as we move on into the future. And today, what we have are hand-tuned models. Those simply do not work, and we need compute to catch up and provide us with ways to meet those simulations. And this team was able to hit over 1 exaflop of compute as they go along solving that problem. It's really remarkable stuff, and like I said earlier on, you can go on Google, on Google Cloud, you can rent NVIDIA GPUs and scale them with Kubernetes and get yourself this sort of power for a couple of hours as you go about your work. Almost to summarize some of what I've been saying so far, NVIDIA has the most adopted platform for HPC so far. Starting from 2012, when that line I showed you, the green line, 1 million developers in CUDA. Now it's over 11 million developers. We take an application approach to HPC where we work with developers to accelerate the applications. And today, we're accelerating over 580 applications, including the top 15 applications, and of course the supercomputers I mentioned earlier on. Similarly, most adopted platform for AI, and that's because of the fact that we have a universal platform approach that accelerates all the frameworks you can want to work with, be it TensorFlow, PyTorch, MXNet, Paddle in Asia, and supports a broader way of networks that you want to experiment with, be it CNNs, RNNs, GANs, whichever solve your problems the best. Exciting to also announce that we are accelerating machine learning now with an open source software offering called Rapids. Right? Rapids is a series of open source libraries that accelerate machine learning. This shows you a little ecosystem of all the adoption and the partners who are using Rapids so far. But more importantly, we can go in and look at how it actually does that. Right? So with Rapids accelerating machine learning, the workflow starts from the data preparation, where you have to handle all the I/O requirements, and then move into the model training, where you have to accelerate the frameworks. On the algorithms. Talking about the algorithms, I'd be interested to see if there are people here who use XGBoost in machine learning. Not yet? Okay. XGBoost is one of the most popular algorithms in machine learning, and Rapids has been able to accelerate that algorithm by large orders of magnitude, up to 50x. And then the last piece of Rapids is the CU graph that helps with visualization and helping you see your insights properly. One of our earliest users of Rapids, this is not on the cloud, but one of the earliest users, which you can take an example from and then go on the cloud and run similar thing, is Walmart, one of the biggest companies in the world, right? What the problem they're trying to solve here is food wastage. They find that about $200 billion, there's about $200 billion of wastage with perishable foods in grocery stores. And so they used Rapids to accelerate their machine learning algorithms 50 times so that they can figure out and better manage their inventory so that they might save on all that cost. So now bringing me to, NVIDIA and Google, how we're working together to provide tools to scientists and engineers so you can solve some of the most important problems and challenges for us in the world today. Repeating what I had said earlier on, together we're accelerating some of the fastest growing markets, right? So whether it's from HPC simulations to deep learning training, deep learning inference, and machine learning. If you're doing any of these workloads, you should definitely consider going on Google Cloud, selecting NVIDIA GPUs, and seeing how they can accelerate your work. We find that a lot of businesses are actually moving to Google Cloud, and if I was to use one word to summarize all of this, is that it's because it's easy, right? It's the ease. Like imagine as a scientist, you want to be working on your life's dream, and you have to wait for approvals from national labs to get space to work. You could just go on Google Cloud and click a button, and you're off and ready to go. Or you have to wait for your IT admin to set up your cluster, right? You can just go click a button on the cloud. Or you want to get access to the latest and greatest GPUs. You're using a K80 in your cluster, but you just heard about the announcement of a V100. You can go on Google Cloud. They're like the fastest cloud provider to offer some of our GPUs, and it's really incredible. In fact, I'll speak to you about the T4, we're excited to announce that the T4 NVIDIA Tesla T4 GPUs are now available on Google Cloud platform, right? We call it the Cloud GPU because of the diverse workloads it supports, and I'll talk more about that soon. In terms of specs, the specs are pretty much driven by the tensor cores, right? The tensor cores give you an ability to do 4x4 matrix multiplications that really help with aggressively accelerating your compute. It offers the ability to run your workloads at multi-inference. We call it multi-precision, right? So at FP16, int 8, and some people are actually experimenting with int 4 as well. You're welcome to go sign up for the early access program offered by Google Cloud. In terms of the workloads it helps with, I mean, it's a universal accelerator. It will help you build smarter applications. It's game-changing inference. You can see the predecessor P4, which is also available on Google Cloud, already gave you 10 times faster inference than traditional compute platforms. And now you have the T4 that's 3 times faster. In terms of video transcode capabilities, you can actually do 4K now for the first time, along with getting double your performance. For distributed training, you can do your training for distributed deployment, leveraging tensor cores like you could with the V100. The V100 is for dense workloads, larger workloads, but a number of customers asked for an earlier entry point, and that's what you can get with the T4. Here are the other offerings of NVIDIA GPUs on the Google Cloud, right? So you have the V100, which I've spoken about earlier, the Universal Deep Learning Accelerator that you can use for deep learning, machine learning, HPC across several regions. And then the P100, which is the generation before V100, and the K80, which was before that one. And then this 2 class of GPUs for inference, visualization, and video transcode, with the T4, which I just spoke about as the new GPU. You can have a look at it over there as well on the side. This speaks to the completeness of the NVIDIA platform. It's not just about the GPU hardware, but also the value you get from the software and the kind of work we put behind the software. This illustration over here is talking about your P100 GPUs. Say you had 4 of them, SC16. It was already 8 times faster, right, than traditional compute for HPC. But then every month, we go about improving this software and packaging it and deploying it for you to use. And you can see how that increased month over month to, say, SC18, where now you have 16x. That's twice your performance on the same piece of hardware without doing anything. But then, of course, obviously, with Google Cloud, you get access to even the latest GPUs, and then you go beyond that, above the charts. All that software, you can find it in what we call NGC Container Registry. The NGC Container Registry is present on the Google Launcher, on the Google Cloud. It provides you containers, tuned and optimized software to work with NVIDIA GPUs. Provides you with containers for deep learning, for TR44 for inference, for rapids for machine learning, as I spoke earlier on, and several containers for HPC. Now to speak about some customers who are already using GPUs on Google Cloud. On the HPC side of things, we see Schlumberger, right? That's one of the largest oil and gas companies in the world. And what they're doing over there is that's an RTM analysis. It's a subsurface profiling of the ocean to figure out where the oil is, right? And they have to do this very quickly and very accurately because any mistake can cost tens of millions of dollars of loss. So it's very important to do this properly. On Google Cloud, they've been able to access thousands of GPUs, scale them with Kubernetes, and achieve over 70 petaflop of compute power. That's truly remarkable and incredible. On the AI training side, there's a startup called AI Sense. They have an app called Otter, O-T-T-E-R. I actually have that on my phone. It's a note-taking application, and I use it in meetings today. Say you have up to 4 or 5 people speaking, it would transcribe everything they're saying, basically voice to text, and you can go back and search through those texts later in the future if you need to use that information. That takes hundreds and hundreds of recordings to train such a model. That could typically take you a month or two on traditional compute platforms. And you can imagine how much that would cost. But we're able to come on Google Cloud and leverage NVIDIA GPUs to do that in just a couple of days. Shazam, many of us might be familiar with Shazam and how much faster it has gotten over the last couple of months or year. That's because they're running with Google Cloud. That's because they're running with NVIDIA GPUs or Google Cloud with all the infrastructure. They're doing AI inference on their real-time AI inference and providing next-level service for their customers. So I'll start to round up and reiterate the earlier point that if you're running any accelerated compute workloads, you should be considering doing that with NVIDIA GPUs on Google Cloud Platform. We build the world's fastest and most powerful supercomputers, and you can rent them on Google Cloud for all the benefits of the insights you can get out of your data. You can build across your global team and work with the tens of thousands of partners Google Cloud has at a pretty low cost. And you can get all of this, including the software, with NGC optimized containers. So the message to you is to go out and try it today, right? You can leverage the $300 free credit from Google Cloud, POCs, support from deployment services from the Google engineers and NVIDIA DevTech who are available to help and work with you as you build out your solutions. And please come talk to us here at the Google Cloud booth or the NVIDIA booth. Sign up for the T4 and sign up for Rapids. With that, I'll see if there's any questions. Thank you. Any questions? I think we're good.